All right, here's the question. A ladder with a length, and it's basically resting against the wall and it has some, no friction on the wall. And we can guess why, because the friction on the wall, probably there is some in real life, but it's negligible probably. And then we have 800 guy plus the weight of the ladder, which if you want to do the weight of the ladder, it probably some kind of integral stuff that they did. Anyways, applied it, so we just idealize it 800 newtons over here to make this question solvable by hand. So what we have to do is basically, first let's look at the summation of fx equal to 0, because it is technically a static question, which means all the force must be 0. We get over here that the force over here, so there's only cx and there is cy, and then there is ax over here. We know ax minus cx equals 0, so ax equals cx. This is really useless. So we go to fy instead equals 0 and see what we can get. With that said, we get 800 as a negative. So let's just start with 8. Actually, it really doesn't matter. Let's do 800 over here minus, and then it's going to be plus Cy equals 0, which means Cy equals 800 newtons. Okay. Now, next, we usually traditionally do straight go to moment equals 0 next. But notice that basically we don't have all the length scales yet. We need the length scale over here to even consider it. Because we need that, and we also need the length scale over here because of that. And why am I saying this? Because we're gonna definitely use C because we get rid of two forces, which is the Cx and the Cy. So we're definitely using C over here. And to do that, we need to get this length, which is basically a similar triangle because right angle over here, this is definitely also a right angle. So we're definitely gonna use that factor our advantage basically. So and that's gonna start with us doing this. We're gonna do big triangle over here with 70 and 10. You already probably can guess what I'm going to do. We're going to transform this to sine theta, which is sine of 70, equals x1. So x1 is the one on the top, and then 10. So 10 sine theta equal x1, which is theta is 70 at this point. Why? I don't know why I put that in there because it's 70. So if that's true, how do we get the other one, right? We need this one too. So x1 is found. x1 equals 10 sine of 70. But here's the thing. Um, we can figure out this one first. Let's just call that x2, and this is x3. So x2 is x1 squared plus x2 squared equal, I don't know, the r. So r is 10 squared, which is meaning if we want to figure out x2, we just have to do x1 equals square root of 10 squared minus x2 squared. So that is basically saying, oh wait, that's wrong. X2, sorry, and x1. Now, with that said, I can get my calculator out, right? And then I can just write second square root of 10 squared minus whatever this is, which is, let me just do that real quick. Well, 10 sine of 70 parentheses is like 9.39692. And with that said, we can do 10 and this squared and then square root of that. So I get x2 equals 3.420214. And then we need x3. So here we can do something called similar triangle analysis. So we can do 10 and 7 over here, 10, 1, and 7. And then we can look at what this ratio is, x2. What we're trying to figure out is x3. So we should probably put x3 at the top to make it easier for ourselves. So x3, ratio of that we're looking for is x3, and we have 7 as our ratio for this. And then 7 is a ratio to x1, and x1 is a ratio to x2. So x3 equals 7, x2 over x1. So in this case, it's 7 multiplied by what? 3.4202 1 divided by 9.39692. And 2.5, that makes sense. If it was bigger than this, it wouldn't make any sense. So we can just say 2.54860. Now we got all the variables we need. We don't need any more of this math. Just erase this real quick. Now with that said, we have this x3. So do we need anything more? No, I don't think so. So we can do a moment question over here now. The moment on, let's start with A. Moment of A, right? Because we need moment of A plus moment of A in the x direction, moment of B in the y direction equal to 0. And there's no other moment if you're saying this is a summation at moment C equal null. With that said, A is a force, so we need to do AX. So AX over here, multiplied by 7. So the distance of the, I mean, do I have to like do that? No, I'm just gonna write well, it's x1, right? This is x1. Don't forget that one. This is x1 plus moment of b. I mean, why not? Moment of by equals 0. So ax x1. And over here, we see, I mean, we have to use a right-hand rule. So this is actually negative. My apologies. Right-hand rule, negative. Over here is positive. So plus b, and it's going to be a y. And it's going to be parentheses. Well, clearly this is going to be x3 equals 0. So in this case, we know everything. We can, am I forgetting something? No, I think this is the right way. Um, AX, why is my pen not working again? Okay. I mean, there's multiple ways to do this, but I think this is the most clear, obvious way to do it. And it's minus minus by x3, x1. So let me just do that real quick. 800 division, multiply, but x3 is 2.54. 860, and then x1 is 9 point. You should always try to make this more visible because if you don't get the point right, then what happen is that you're kind of, I'm talking about these periods over here, because your calculator desperately needs the right period, or you get the wrong answer. I get B. I get 216.973221. So there we go. AX equals that. And guess what? AX equals CX, so this equals C. So CX. So we should be correct on saying it's B, right? So I'm just gonna assume that I'm correct, and then you guys can double check it later. I'm sure I'm correct. All right. Next one. All right. Sign has a mass of 150 kilograms. The sign is attached to a wall by a hinge at point B. Okay, there's a hinge over here. There's a cable supporting it. So there's a force over here. I don't know what this arrow is about. This arrow is probably a mistake. I'm assuming because that doesn't even look right. Um, there we go. I don't think that arrow is supposed to be there. So the side of the mass is 150. The side of the mass is touch a cable pinned. Okay, so obviously the A is just going to be angle like this, not going to be anything special. You can even say this is a reactionary force, so we can actually do force 1 equals force 1 over here is basically the same force. Actually, a lot of people like to use T, and then in my class, we would do TAC over here. With that said, there's a force downwards because of the mass of the whole thing. And I think we're good on that one. There's this kind of force, I think, if I remember correctly. Yeah, because this is a hinge, but there's no moment control on that one. That's true. It's not fixed. Yeah. The sign is attached to the wall at pin B. Determine the tension of the cable. Okay. So what does this do to me? All right. So we can actually simplify this a little bit. My question is how much you want to simplify? Well, that's your choice. You can make this because I don't think the 4 meters matter. I think you could just write mg at 2 meters. So this is mg over here, and you can move on from that because it's symmetrical. I think that's good enough. So this is an interesting question. First of all, we have a hinge over here. We have a point over here and we have a point over here. So a tension line, this is equivalent to saying this. So this is T1 and T1 equal TAC is what we call it, and is on tension. So with that said, what we're going to do is we have to also consider the mass of this thing. And because the center is a great place to put the mass, we're going to call it mg center. So it's 150 degrees. So that's basically saying 150 multiplied by 9.8 equals whatever this is going to be called. What should I call it? Just weight. So we'll call this weight W instead. And we know it works at 2 meters because it's a rectangle basically. So the center is always where the thing happens. What it's trying to do is determine the tension. So let me just recreate this a little bit over here, where we have actually we can do it over here. We can do a force this way and a force that way. And there's a force this way. And I'm pretty sure that's pretty much it because there's no other forces I can see. I'm seeing already B Y, B, X, and then I see over here C tension. So we can just call it TAC, right? That's pretty clear, right? TAC. Yeah, TAC. So first of all, we need to get this angle over here. We'll just call it for now angle, theta. With that said, we can first focus on the summation of force in the y direction equals 0, right? With that said, what's the y direction first of all? So we can always say we have I already claimed that by is in the positive direction for now. We have claimed that the w is in the negative direction for now. We have claimed the tension TAC with this angle. So this angle projects this way, which is the side over here, which is going to be sine of theta equals 0. Yeah. And this sine over here will be classified as sine theta will be classified as 1.5 divided by square root 1.5 squared plus 2 squared. So that would be on second square root 1.5 squared plus 2 squared equals 2.5. So it's like 1.5 divided by 2.5. Summation of fx equals 0. We can do bx over here is positive, and then we can do minus TAC cosine of theta equals 0. So now what information do we know? We don't know B. We have too many unknowns. We have AC, we have BY, and we have BX. There's nothing we can solve with this. So with that said, we need a summation of all moment in the z direction equals 0. With that said, which one would be the best? I think it is the moment on B. So we'll choose B over here. So with B over here, we need this distance, which is 2 meters. And we need this distance, which is not given. Let me double check if it's not given. Sometimes it doesn't. No, it's not given. It's totally not given. Okay, we have a problem then because the moment on that is needed. Um, hmm. Okay, I'm having a little bit of trouble because there should be a link over here to get that moment out, right? Oh no, I'm stupid. I'm stupid. Sorry. This is going this way, so the moment there's no moment going this way. I am flabbergasted on my lack of reading skills sometimes. Anyways, we find that we have to do a bunch. Oh, maybe I should have done TAC. TAC might have been easier because TAC. Oh, we're trying to get tension force. So no, moment is right. So we have the right hand rule is negative first. So negative W, right? Parentheses 2, right? That sounds about right. And then it's going to be for the oh, so it's going to be this way and that way. That way is in it is a directional 0. So the only thing that matters is the y direction. So this way is positive, so it's plus TAC. Is this way is positive, so it's sine, right? Sine of whatever angle this is, theta. So equals 0. So we have what are we trying to figure out? We have T. Oh, do we not even need to do any of the force moment? We could just do the moment. You see, this is why you have to check sometimes that be smart about this. This one was a moment question. You did not have to do any of the other stuff. You could have done TAC equals W negative 2 sine of alpha, and you're done. Yeah, yeah, I wasted a lot of time on that shit when you didn't need to. So let me just do this in my calculator, and I'm gonna double check if I did anything wrong. Always do that. Division 1.5 divided by 2. Okay. Okay, I did something wrong, obviously, because that seems ridiculous. What did I do wrong? Did I do something wrong? Oh, yeah. Yeah. I forgot to multiply this by 2. So that's 2 over here. My apologies. That should have been. Okay, I got an answer. That's not ridiculous. I got this one. So I did it this way because it's easier, but you could have inverse sine. Let's do inverse sine for you guys because it might be better. It's 36 degrees, and with that 36 degrees, you could have put 36 degrees equals alpha here too if you want, which basically turns it into division 1 negative 150. I just want to show you different ways of doing it, not just my way of doing it. Also, this is a positive because it goes to the other side. Don't forget that. Sine of 36, and then you can have done multiply by 2, and then that gives you the same answer of 2450 newtons. Same way, either way, gives you the right answer. I recommend you do it the way I did it because it gives me exactly 2450 newtons, but your choice of doing it, I don't care. It is B. The way I did it was basically TAC equals weight 2, and then you did 1.5 divided by 2.5, and then multiply by 2. And that way it's easier, but I understand that that's not practical sometimes. I don't know why would it be practical, but for some reason it's not letting me type with my keyboard, which is interesting. Let me pause my thing and see what's okay. I don't know what was going on, but I couldn't type in B. B is there. I just had to reload everything and do it again. Over here, we have 100 kilogram bar resting with a frictionless incline. Four-star apply. Oh, it's frictionless. That's impressive. The reason I'm impressed by it is because usually you don't get that question. That's interesting. Anyways, A 100 kilogram block rests on a frictional incline. Force are applied to the block shown. What's the minimum force P so that there's no downward motion occurring? So this is basically saying, hey, do you know your algebra? Actually, I don't think it's that, but basically what you do is have a block over here, right? And you have a force like this, which is 100 multiplied by 9.8 equals the weight of this thing. And you have this angle over here, which is 30 degrees. And you have to figure out what are you trying to do. So you're trying to get the y direction over here or the sine direction over here. And in this case, we're trying to get the sine direction over here. I don't understand why there's a 10 newtons over here. I'm not sure if that's intentional. Yeah, I really don't know. I don't know why you would explain that. I'm guessing is to show this force over here. Yeah, wonderful, cool. Which means you can reverse engineer and solve it a different way. But you don't need to do that. You can just do sine of, oh, no, there's no reason for that. Why even put that question? And what was the point of that? Because all you need is a summation of fx, which shows that then this p must equal minus weight of sine of theta equals 0. Therefore, this is it. But why would I don't understand this. I don't understand why they showed that portion. I still don't understand what they're doing with that. So what a waste of time. It is C and move on because this is just a Jen question that someone made probably right while they were drunk. Um, yeah. Honestly, the question wasn't bad. I just find that this 10 newtons is like useless. Why are you doing it with a 2 and 1? That's the only reason I'm like, why are you doing that? Anyway, the experiment is performed to measure the frictionless force between the block and the incline. Ah, yes. Okay, so how this works, and I'm going to explain it. I already know the answer because it's really obvious once you know it. When you're trying to push some object anywhere, there's a frictional force over here. And let me make sure there's a friction here. Is there a friction here? Actually, there's a friction force. Measure the friction force. Yes. So there's friction over here. So what happens is that to even overcome the friction force, because incline. So here's how it works. It doesn't move. No matter how much you push it, it doesn't move because initially because there's a friction force, and the friction force is a refraction force. Force friction is actually less than mu. It's like this. It's equivalency. So basically, it's less than until it's equal to, and then at that equal to, you are making a force like here. You're creating a maximum here. This is where this is the region where mu s equals something smaller than mu kinetic. Now over here's a region where mu kinetic, because kinetic force, because think about it, when you're stationary, the roughness is more interact. But if you're moving it, if it's moving it, you're kind of like swiftly like only if it's in motion, not all the jagged parts that gets to interact with each other. So you actually dip down to over here to a new level, which is this is the profile of something that is has friction in it. You might be saying, oh, okay, that's cool and all, but none of these actually have it. Like this one doesn't have it, this one doesn't have it, this one doesn't have it. Well, this one does have it, but it's inverted. Why would that be? Well, in this case, it's basically the orientation, I think, because friction force, they probably put X and Y over here, and this is positive direction. So they did negative direction, so they did a negative like that. So it is D. It is clearly just D. They should have definitely put some kind of like markers over here. I don't know why they didn't do that, but I don't care enough to know why they wouldn't do that. It's not my problem. Um, it is my problem. Yeah, anyways, two spheres, one mass is 1.5 and the other is 10 kilograms. Okay. On equal, yeah, okay, so they don't move. Equilibrium. If all surfaces are frictionless. Oh, surface is frictionless. Amazing. I love that. When it's not friction, it becomes usually easier. But not this time, I don't think. If all the surfaces are frictionless, so it means that normal to it is the only thing that matters. And this assumption is very powerful because you might not think about it, but this analogy applies to a lot. What the normal is, you don't count the friction because the friction is way harder. Huh? In all of fluid mechanics, getting a normal in order, we get it. So there's like a real understanding of the normal that needs to happen here eventually. You might not understand it right now, but in the future, when you do fluid mechanics and other stuff, the normal becomes a very interesting simplification. It becomes a very powerful simplification that simplifies so much things. It's just yeah, it just simplifies so much. I don't know. I'm just glazing it too much maybe. But because we're doing normal, we have 60. We have point A and we have point B. Now, clearly, we know that this is 4, this is 4, this is 5 to it, right? Not that it's actually helpful, but we actually have a force that down. So, okay, so we have something like this. And it looks like it's a very much a geometric problem more than anything else. What's the magnitude of the reaction force on B? So, okay, so over here, right? We have to figure out this is 90 over here, right? this angle because what we have is basically this, but we cannot do anything without knowledge of the angle that it is putting itself in, this angle. This angle is what we need to know, all right? And I'm trying to think of how to do that because I would traditionally have done what we call a normal for a normal dot product, but I think there's an easier way to do this. I just have to find it, right? And I think I got it. Because if you look at this, look at how it's structured. This thing, right? This is 45 degrees, right? This is 45 degrees. You need a 90 degrees over here to get it to here, right? So if this is 90, and if you put a 90 degrees over here, you know this is 180. So 180 minus 75 minus 90 equals, and get your calculator out. 180 minus 75 minus 90 equals 15. So this is 15. Got it. So this angle is equal to 15. The next one over here is next. And we do the same process over here to probably just get something. And now I know how to do it. You just have to change the 75 to a 60. The same process. Oh, we get 30 here. Equal alpha. Okay, so we have the two forces. Force A, so FA and FB. Now, what we know was the magnitude of the reactionary force of this. So this is look at the external, right? And there's a few ways, and I think we will not need momentum here. We will only need a summation of forces. Look at the summation in the x direction must equal 0, right? I wish I had more space. Yeah. But if I do FB, because third law, you'll see what I mean by third law, but they must be equal is what I'm saying. And yeah, that's all I'll say. Oh, because actually I just realized what I needed. Over here, 10 kilograms, and this is 4.5 kilograms, right? So now we can actually solve this question. I'm being so foolish by not doing that. So summation of fx equals 0. So we need fb cosine of 15 is in the positive direction, and then minus fa cosine 30 equals 0. So we know there's a relationship between fb and fa. Now we know that there's another relationship, a summation of x equals 0, which is basically saying 7.5 minus 10. Here's the thing about statics. You need to be careful about your notation. So I recommend being careful about negative and positive. Such a messy thing if you get those wrong. And both of them are positive. So FB, the sign direction, as you can see, sign direction. Um, Sine 15. Oh, this is gonna be a messy. Oh my God. Sine 30 equals 0. Yeah, it's gonna be a really messy equation because you have FB, FA. I'm not gonna actually like solving it. Great. Because it's a messy equation, yeah. Is there an easier way like when matrices? Probably not. Let me just put dot over here. I'm just gonna look at it for like 5 seconds to see if there's like a easier way to do matrix way to do this. I don't think so. If there is, I'm just not seeing it. So I mean there is probably. I'm just not seeing it. Actually, there is 100%. I just don't want to do it. To tell you the truth, I know how to do it. I just don't want to do it that way because then I need to bring out my calculator more, and it's just a calculator question. Then, I mean, it is still a calculator question, just less so because of that. So we plug this into here. Minus 17.5. Actually, none of these questions can be solved without a calculator, by the way, just so you know. Plus FA cosine 30, unless you bring your own chart, which by that point, what are you doing? I mean, sure, it's beautiful that you have your chart, but what are you doing with your life? FA sine 30 equals 0. And then we have FA parentheses cosine 30, cosine 15, sine 15 plus sine 30 equal 17.5. And then we get FA equals 17.5 divided by the whole thing, which I'm going to rewrite because I do like writing the whole thing. FA equal 17.5 divided by parentheses cosine of 30 divided by cosine of 15 sine of 15 plus sine of 30 parentheses. So 17.5 divided by parentheses fraction cosine of 30 parentheses cosine of 15 parentheses sine of 15 parentheses plus sine of 30 parentheses. And that only took like a few seconds. that equals FA, right? FA. Yeah. Oh my God, I wasted my time on FA. But here's the thing. I think I made a mistake somewhere. Oh, right. Yeah, that seems too small. Uh, this is supposed to be multiplied by G. My mistake here. Multiplied by G, multiplied by G. I knew something was off. Multiplied by 9.8. Yeah. So this is for FA. So we have to figure out FB. FB, you go back into this equation, which is over here. I should have done FA the other way around to make it easier for me. I did not, and now I'm paying for it. Cosine 30, parentheses, cosine 15, parentheses, enter. I got 210, am I right? I think I am. I don't know, but I think I will just accept if I'm wrong. You guys will scream at me, hopefully one of you will. If not, then I'm always right. So here clearly, well, I think they even give you a hint over here. We'll see what the hint is, but uniform log of length L is inclined 30 degrees. Okay, so I don't know why you would need 30 degrees, but here's 30 degrees. From the horizontal, when supported by frictionless walk, locate the 0.6 and so it's like a rock over here. The mass of the is about 200 kilograms, so this is 200 kilograms. Engineer mass, so engineer is apparently 53.5 kilogram walking along the log from left to right. So it's going from left to right. So this is how we're going to define our variable. Okay, so it's going to be balanced horizontally, and usually it's from my left when we do these questions. And I was confused about that a long time ago, but we're going to do it like this. So with that said, I'm thinking this is a hint, and obviously the total mass, we're going to do mg over here, basically. So if that's the case, it's 0.5, and then from this rock, that's 0.1. So if I were doing a moment, what was this? I don't know what that is. Let me just clearly cover that because I don't know what that is. Okay, so moment on this, right? Maybe do this one, I don't know. All right, moment on this, we're doing a moment. So let's just do a moment in the Z direction because that's what we always do, at the rock. Equals 0, the summation. All right, so we begin with 0 0.1 left, so it's negative from the rock. So this is 0 0.1 L, because of how it works, this 0 0.L. And then we're doing, that's a D, this is D over here. So we have to multiply by the mass, which is 200 kilograms, multiplied by, so it's mass times 9.8. Okay, so next we have to do the human, and we're doing it from this scale over here. So, but we want to get rid of this part because we want to reframe it. So we're going to do 53, and we're going to do we don't even know what direction it is yet, but yeah, we don't know what direction it is actually. Let me think about this a little bit before we begin. But we're gonna do plus or minus for now. And actually, this is the positive direction, sorry, because it's this way. It's negative, but if you look at your right-hand rule, it's a positive direction. So, but because it's positive, it needs to be negative because this force has to equal 0. And then the only way for that to happen is if this is negative. Okay. So that in that case, we do over here x, right? But we want to get to here, so we have to include 0.6 somehow. We want to get it to 0.6. But right now, if I were to draw something like x over here, like x equal, I don't know, 0.7 L over here, it would be disingenuous. It would say something like it's something like 0.7 L. So we need to minus that over here, and this equals 0. With that said, what we can do now is simplify. Because we're trying to get this portion over here, we can move this outwards, so um we can do it's just algebra at this point. So we can do x, right? So it's gonna be let's do it over here. Let's do x equal negative, and then negative and negative again. So it's going to be 0 negative over here, and it's going to be divided by negative. So 0.1 L multiplied by 209.8, parentheses, divided by 53.5, right? And let me just clear this up a little bit. Divided by 53.5, right? And then it's going to be minus, it's going to be plus, sorry. Well, it's going to be plus and then negative, so it's going to be minus 0.6 L, right? Right. So this is going to be minus, this is going to be plus, oh, it's going to be plus. Okay, let me just do this real quick. I'm just not to the L 9.8, right? It's going the other direction, so it's minus, right? And then this is going to be equal to negative 53.5x minus plus 53.5 x, right? L, right? You're going to negatize everything by negative 53.5 and negative 53.5. Don't forget the 0.6. And with the 0.6, you're going to do positive over here, so it's plus 0.6 because of negative and plus over there. Okay, we got everything. This is negative, so it's plus plus. So that's how you get it. That's the full one. So if I were to do the calculator now, get this portion over here, on 1 multiplied by 200 multiplied by 9.8 multiplied by 53.5. That's 3.6635 L plus 0.6 L, which equals that's plus 0.6. So, wait, did I do something wrong? I did something wrong, did I? There's no way that is that. Oh, I forgot G again. Oh, G, 9.8. Okay, so 0.3. So 0.37, something like that. I need to keep it, I need to remember G sometimes. I'm forgetting G all the time. 3.73831776, and then that's going to be plus 0.6, which equals to 0.97383317 L, which is D. We have answer for that one, which is D. So I'm just going to put this over here, D. So there is there are three non-parallel non-zero forces. What of these are true? So they're asking me which of these are true. The force must be concurrent, so that means that these are at the same time. Same time. Non-zero forces. It might be true because this force and this force could happen at different times, and it could be a messy situation or something like that. I don't know. The force must be equal in magnitude but opposite in direction. No, actually, because there's three of them. There's three. Oh, and it's non-parallel. Read this carefully. Non-parallel. So there's no like this. It's non-parallel, and it's in equilibrium, right? Yeah. So can't create a moment. So this is actually terribly wrong. The line of action, yeah, that's not even close to anything I would say that's correct. Line of action is usually the place that's rotating, like this line of action, rotation, the cross product of that. I don't know why they would even put that. The force must be what the fuck are they saying? It's obviously A. They have no, I don't know what the other choices are, but it's clearly A. Like there's no other one that 250 block. Oh, wait, this is a pulley question, so I might struggle a little bit on it, due to me not doing a lot of pulley questions. I might have to look things up. So the mass of the block M is 250 kilograms. By the static pulling mechanism shown that the static will assume the mass what is mass two. So this over here divides the mass in two. So basically it's all right, I'm gonna multiply by that just to make my life easier. So 250 multiplied by 9.8 is about 2450. Okay. So with that said, I can divide by two, which is this has 1225 as in the transfers up to here. So it's 1125 that we need. And this force must give that much back uh with three cuts over here. So these two must again be 1225 if I remember correctly. And then this one over here must be 1225, right? Am I flipping here or not? I might I might I might be flipping here, but it feels like if this is 1225, then this must be 250. I think this is a bullshit question. It is B, right? It's a bullshit question. Whatever. I think it's B. All right, this is